So let's do a graph real quick. You guys know what a quadratic is, right? Something like this. We've also studied them in parent function form, or what we call vertex form. Those are quadratics. So go ahead and put this first one in your calculator. We'll graph it in labels, graph it up. If you know how to find the zeros, go ahead and do it. You got the function? X squared minus 2x minus 4. And my window's not very good. Zoom. You need the zoom standard. A lot of times when we're looking for zeros on a quadratic, it's going to be fairly reasonable. Can somebody tell me how to find the zeros? Exact. Pretty close to exactly. Using the calculator. I think you can get it out. Second, yep, calculate. You can hit 2 there if you just want. So that's 1 0, correct? So I need to go to the left of it. Hit enter. Then I need to go to the right of it. And hit enter. And I need to guess. So I need to put my cursor right where I think it is. And there's my 0. Negative 1.236. I want you to go to 3 decimal places. And then, of course, the y value is a 0 because that's what we're looking for. Go ahead and do the other one. And if you need help, please tell me. What we got? 3.8. What's the y-intercept of this graph? What? The constant is the y-intercept. So if you want to, now it's really easy to graph by hand. You have both the x-intercepts and you have the y-intercept. You know what opens up. If this is positive, you graph it pretty easily. Exactly. We've been sketching them. Now you can get a little bit more precise. Are we good there? Handle that one? I'll take that as honest yes. So method one is graphing. Is it exact? No. Does it always work? Yeah. So we will talk about this. For every method we use. Okay, so for graphing, it always works, but it's kind of inexact at times. In business, okay, 3 decimals is probably okay. But if you're doing something like astronomy, you have really, really big numbers and you need to be really exact, you're going to have to do a different method, algebraic. So keep these in mind. We'll talk about them with every one of these methods. If you can factor, factor. That's my advice. The shortest, easiest route. But it doesn't always work. That's the thief I have with factoring. It doesn't always work, but it's exact. And the answer you get from factoring is the answer. Perfect. So, you guys remember how to factor at all? Okay. So, we need, does anybody know what the factors are in that quadratic? How do you do that? What? So if you're explaining this to somebody else, how would you say this is how you factor a quadratic? You want 2 numbers that multiply, and I need to add here. That's for this number is 1. Okay, that only works if this number is 1. Right? So 1 times 1 is 1. 1 plus 1 is 2. The next couple examples, you'll see you have to check these 2 as well. X times x is x squared, right? So keep that in mind. What are the zeros? Okay, Katrina. In this case, you probably don't need to do this. You can just see that -1 is the answer for both of them. Right? But sometimes they get a little more complicated. And you need to split it and actually solve those equations. But at this point, I would accept you skipping this step on easier ones. Okay, no problem there. So what does it mean when those 2 are the same? What does a graph look like? It hits the x-axis at its minimum or maximum. So just keep that in mind. What if I give you something like this ornamental? Are there two numbers that add up, multiply to get 4 and add to get 8? Well, we can do 4 and 1, right? That's the 5. 2 and 2. Like I was saying, this has some bearing on it now. Okay. So, we know it needs to look like that, right? So one way to do these is just to start throwing numbers in. No, it's not, because 3 times 1 is not 4. We still need these to multiply to get 4. 2 and 2? 2 times 2 is 4, right? Yeah. Okay, so let's try that. So now you can FOIL it and see if you get your original. This method gets a little bit tedious. FOIL. First, outer, inner, last. Does it work? Yeah. Check. I think on this one, in fact, 4 and 1 works as well, if you arrange it properly. No, it doesn't actually. It just happened. Okay, so we just happened to guess right. What are my zeros? -2, right? And if you can just look at it if you want, subtract 2, divide by 3. If you need to, set them up and solve. If you need to. There is another way to solve those. Some people find it easier. You guys know what a Punnett square is? Yeah. Oh, biology, maybe biology, genetics, right? Okay, so I kind of hijacked the Punnett square, and we have to use it for that. Here's method 2. I have no idea if that's what it's formally called in math. Probably even not, but I just hijacked it because it makes you guys fun. But it does make solving these a little bit easier, in my opinion. Put your first and last numbers in there. Okay, you know this has to be 3x squared, this has to be 4. These two here need to add up to 8x. So our goal is to kind of figure out what we need in there. But I know that this needs to be 3x and x, correct? And now all I need to do is find combinations of 4. See if it works. So let me try something I know is wrong. 4 and 1. Because 4 times 1 is 4, right? That makes this 3x, which is 3x times 1. And that makes this 4x. What do we add up to? Is that right? No. Right. See how that tells us it's wrong? I find this easier than plugging and chugging. But it's up to you. Let's try a different one. We know the right answer is 2 and 2, right? Because we did it already. So we get 6x and 2x. Those give us 8x. And we're good to go, right? So we can see our factors. X plus 2, 3x plus 2. And they match these two. Okay? So pick either one. I don't care which one you use. I'm not going to say use the Punnett square. If you think the first one's easier, awesome. Great. Fantastic. Do you have any questions on any of these? Again, first try, factoring. Try it first. If you can factor, the problem's the easiest. All right, let's try one more. What are the zeros of that function? Try it on your own. Yep. Factoring, by factoring, not by graphing. X plus 1. That might work. Some people are this fast on this. Anybody help figure that out? Questions? You may got the answer. Side David or from David? Dave. We're trying to get that. What are the factors? Yeah, 15 here and 1 here. But I think that would work. Yeah, what are your factors? Yeah. Okay, those multiply to get 15. They add to get 16. It's x times x or x squared. Alright, can you solve? What? I got negative 5 over 2. What are your factors? 5 and 3. Let's say what are your factors? I mean, what are your 2x plus 5 plus 3. Okay. Does anybody agree with that one? David doesn't agree with that. Okay, 3 times 5 is 15. 2 times 2 is 4. This is 6 and 10. Those add up to 16, right? So yeah, I think you're good. And my zeros, negative 5 over 2, negative 3 over 2. Okay. Any questions? All right. It's not Friday. Okay, keep in mind here, number 4 and 9 ask you to use completing the square and what's the other one? Wow, that's amazing. Quadratic formula, that's what I forget. So tomorrow we'll go over those, so don't worry about it. If you're running the board, you can wait. Friday I won't be here, so we'll just make it due Tuesday. I suggest you don't wait till Tuesday morning to do it. Yeah. You can crawl out of bed an hour earlier. Physically, you can't get out of bed at 6 o'clock in the morning. You're a sad little man, and you're not migrating. Make me worry. What time do you get up? This morning, 4:30. Complete another 4:30. I do it. Yeah, there's a group of us that do workouts in the morning.